Hello, my wonderful math students, and we are going to be working on the unit review on vocabulary review. We are finishing, we are finishing, I think it's unit 5. Yep, because we're going on to unit 6, so we're finishing unit 5. So we're going to do a unit review. We're going to fill in the correct word for the blank. Our words that we have are array, decompose, multiplication, product, unknown. When you blank, you break a number into different parts. When you break that number into different parts, we know, we use it so much, it's decompose. So you're going to put decompose here. I'm going to mark it out. Then I'm going to go on to number 2. You can decompose a factor into a blank fact to help you find the product. So decompose a factor. So I'm going to make these are factors, because factors are in multiplication problems. And if I decompose it, it means I could break it down to like 4 times 7 plus 4 times 7. So we're breaking it down into what kind of a fact? A multiplication fact. Well, I might have to float my word a little bit there. Multiplication fact. The blank is the answer to a multiplication equation. Answer to a multiplication equation. We know the answer to a subtraction problem is called a difference. The answer to an addition problem is called a sum. The answer to a division problem is called a quotient. The answer to a multiplication equation is called a product. Alright. Arrays can be used to find the blank in a word problem. Alright, we've got 2 words left, array and unknown. Arrays can be used to find the array in a word problem? No. Arrays can be used to find the blank or the unknown in a word problem? Yes. Remember, our unknown is just what we are solving for. So it's what we're used to as a question mark, but we can put a letter or symbol in there. And a blank is an arrangement of objects in rows and columns. Rows and columns. We talk about that all the time. It is an array. So we mark out array, we mark out unknown. I'm going to flip that page to page 194, the next page, 194. And we're going to be on number 6. Number 6. There are 3 bags of marbles. Each bag holds 4 marbles. Which equation can be used to determine the number? Now, if I'm thinking about this, alright, and I say there's 3 bags of marbles, and each bag holds 4 marbles, so I know that's going to be 4, because 1 bag, 2 bags, 3 bags, and each one of them have 4 in it. So that's repeated addition or multiplication. So, which equation can be used to determine the total number of marbles? So let's look at the first one. We have, they didn't put it in parentheses, so I'm going to put it in parentheses. Alright, so we have 3 and 2, so our 3 factor is staying the same. So our 3 factors staying the same. When we add these 2 back together, are we going to get 4? The answer is no, so therefore we cannot get that one. So therefore it cannot be correct, so I slash and trash it. The next one, I'm going to go ahead and put my parentheses around it. My 3 stayed the same. Can I add my other 2 together to get to my other factor? I can. Now I need to check my signs. Multiply, multiply, and then we add both of our multiplication facts together. So this one is correct. Put my parentheses in again. Now I hope you're doing all this on your page, because you should be. Alright, oh look, they kept 4 the same this time, so that means if they kept 4 the same, they needed to decompose my 3. So when I put these two together, is it going to be 3? It is not. So I slash and trash that. Alright, I'm going to put my parentheses back in. Just helps my brain. They kept 4 again the same. Is this one, if you put it back together, can it be 3? So it can't be that one either. So the only correct answer would be B. Alright, 7 is, there are 7 cars in a parking lot. So that makes sense of my problem. So 7 cars. So here's 1, 2, 3, 4, 5, 6, 7 cars. And each car has 4 tires. So 4 tires, 4 tires, 4 tires, 4 tires, 4 tires, 4 tires, 4 tires. Which equation could be shown to show how many tires total are in the parking lot? So I know my equation is going to be 7 times 4. That's what my equation is going to be. So let's look at our equations. Put my parentheses around them. My signs are correct the way that they are. 7 didn't change. When I add 4 and 1 together, do I get 4? I do not, so I slash and trash that when it's gone. Put my parentheses in. 7 stayed the same as one of my factors. Can I put my other 2 together to get to my other factor of 4? I can. Let's check our signs. So 7 times 2, yep. 7 times 2, yep. And then you add it together because they're partial products. So that one is going to be correct. Put my parentheses in. Did 7 or 4 stay the same in either one of these? Did one of the factors stay the same? 2, but 2 isn't one of our factors, so therefore can't have that one. Slash and trash it. Put my parentheses in. Alright. They decomposed my 7, but did they keep 4 the same? They did not, so I slash and trash that one. Oh my goodness. Oh, I got sneezed. Okay. So, now we're on number 8. A bucket containing 8 markers is placed on each table. There are 7 tables in the classroom. How many markers are there in all? So I got to make sense of this problem. A bucket containing 8 markers is placed on each table. So if this is my table, I need to have 7 tables. 1, 2, 3, 4, 5, 6, 7 tables. And I have 8 markers on each table. So this is me making sense of the problem. Alright, so that means that my equation is going to be 7 times 8. How many markers are there in all? So I need to multiply 7 times 8 to figure out how many markers I have in all. There are blank markers. Markers is our unit. So I can break this down. I can do it a couple different ways. I'm going to do it this way. 7 times 5. So I'm decomposing my 8 factor, plus 7 times 3. Alright, 7 times 5 is 35. 7 times 3 is 21. Add those two together, I get 56. So 56 would be my answer. I'm going to move these. Alright. Coach, not really sure. Ko-Fi buys 8 packages of tennis balls. Each package has 6 tennis balls. Complete the equation to show how many balls he buys in all. Alright, so we're going to have to break this down. Eight times 6 equals 6 times blank plus what? Oh, I see. So since if you keep 6 is a factor, right? So I'm going to keep 6 the same. That means I had to break down 8, which is going to give me another 4. And then I've got 6 times 4, which is 24. And then 6 times 4, which is 24. And 24 plus 24 is 48. Alright, the next one. Kelly buys 3 bags of erasers. Each bag of erase has 8 erasers. To find how many erasers she buys in all, she doubles 8 to get 16. What should she do next? Ooh, I like this one. Kelly buys 3 bags of erasers. Each bag has 8 erasers. Okay, so if we make sense of this, she's going to have 1 bag, 2 bags, 3 bags. And each one of them's got 8 in them, 8 erasers. To find how many erasers she buys in all, she doubles 8 to get 16. So she already added these two together to get 16. What should she do next? Well, she should add 8 more, shouldn't she? And then that's going to give her 24. 24 what? 24 erasers. Explain how knowing 2 times at 9 equals 18 and help solve 4 times 9. Oh, we're going to double it again, aren't we? Because we doubled the 2 to get to 4. So I can double the answer, the product, to get to the product of 9 times 4. So 4 times 9 equals 36. Because I doubled the 2 factor to get to 4. Alright, now we're going to move on over and we're going to do number 12. So, let's see what we got here. Now, you all don't have sticky notes, but if you need a piece of paper, you're more than welcome to get that piece of paper to work it out. The school secretary buys 6 packs of large notebooks with 8 notebooks in each pack. Which equation could be used to find how many notebooks she buys? Select all that apply. It's a key word. Select all that apply. That means there's going to be multiple there. The school secretary buys 6 packs. So 1, 2, 3, 4, 5, 6 packs. And in each one of them, there's 8 notebooks. Okay, this is me making sense of it. So that means the equation is going to be 6 times 8 is my 2 factors I'm going to be using. So if I look at this and put parentheses around A, 3 is staying the same, and 4 is staying the same. So it would be 3 times 8, or it would be 4 times 6, wouldn't it? So this one cannot be correct. Slash and trash it. Put parentheses around this one. Which numbers staying the same here? 2, 3, 4, 5. None of them are, so that can't work. Which factor is staying the same here? Oh, well, 6 is staying the same. And then, so if 6 is staying the same, that means I needed to decompose 8. So can I add 4 and 4 to get to 8? Yes. Check my signs. I'm multiplying, and then I'm adding. So therefore, C would be correct. But remember, it says select all that apply. So I'll put my parentheses down here. Alright, 8 stayed the same. So that means if 8 stayed the same, my other factor should be decomposed from 6. So 1 and 5, it is 6, correct? So that one is correct. Put parentheses around it. 4 stayed the same. When we add the next one, we get 5. So therefore that one cannot be the same. It's slashed and trashed. Alright. Going on to 13. Going on to 13. We've got which equation represents how to find the product for this array. So here's our array. So before I even look down here, I'm going to figure out what my array says. It's 3 times 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's 3 times 9 is my equation for this array. So I'll look at the first one. So it has 3 times 9, which is correct, but then they've decomposed it. So they kept 3 the same, and 9 they broke up, so this one would be correct. Let's look at the next one. They got 3 times 9 again, so that's correct. Put this in here. Is there a factor that stayed the same? There's not, so I'll slash and trash that one. Go on down to C. They've got 3 times 9 there too. Put my parentheses around them. 5 stayed the same. Is there a 5 factor? There is not, so slash and trash it. 3 times 9, they did that again. Ooh, bunches of 3's. So 3 stayed the same. And when you add 3 and 3, do you get 9? Nope, so slash and trash that one. And so A would be our answer. Hope you're making sure to slash and trash and make all the marks that I am. If not, you better go back and do it now because you'll end up redoing it at the end. Fill in the correct numbers to find the product. So we're on number 14. Fill in the correct numbers to find the product. Alright, so we know we've got 8 times 7. So this and this. So one of them would have to stay the same. And since we have 7 here and we have 7 here, the last one would stay the same. And we decomposed our 8. Oh, sugary doodah. Minecraft was still too long. Kicked off our lights. Alright. So, where were we? 7 stayed the same, so we had to decompose our 8. We've got 4, so 4 would be our other answer. Alright. Then we've got we've got what is the partial product. 4 times 7 is 28. And then 4 times 7 is 28. We got 28 plus 28. Well, if I need to come over here and do 28 plus 28, then I know I got 8 plus 8 is 16. I put my 1's down here, carry my 10's over to my 10's, and then 5. So my answer would be 56. 56. Remember, the properties of 8 is we can break it down to 4 and 4, or we can break it down to 3 and 5. Those are the more compatible numbers. Alright, let's move on. We're up here on number 15. Up here on number 15, Denise has 5 packs of pencils with 8 pencils in each pack. So 5 packs, 1, 2, 3, 4, 5, and 8 pencils in each one. This is me making sense of the problem. Which array could you use to find the number of pencils she has in all? Oh, look, they've got it broken down on the array. So, our equation is going to be 5 times 8, right? Or 8 times 5, either way. Go to sneeze again. Oh my goodness. So let's see what we've got here. We've got 1, 2, 3, 4, 5, 6. 6 times 1, 2, 3, 4, 5. 6 times 5, which would not work. Now we could break it up to 4 times 5 and then 2 times 5 and then put them together. And that's what they're wanting you to do. But I know I'm adding these two, so I can count straight across and find my equation that I need. 1, 2, 3, 4, 5, 6, 7. That's 7. 1, 2, 3, 4, 5. That's 5. So that's not it. 1, 2, 3, 4, 5. That's 5. Oh, we got one factor. 1, 2, 3, 4, 5. That's 5 times 5. That's not what we need. 1, 2, 3, 4, 5, 6, 7, 8. Oh, there's an 8. 1, 2, 3, 4, 5. There's 5 on this side, so there's our factor. And look, they did break it down into 1, 2, 3, 4, 5. They broke it down to 5 times 5 and 5 times 3. and you have to add those two together. So our answer would be D would be our answer. Alright, we're looking at 16 now. 16. There are 9 apples in each bag. How many apples are there? So we're having to solve for this one. All kinds of sticky notes on this one. I'm just having a sticky note morning. So there are 9 apples in each bag. So if this bag, so there's 6 bags, 1, 2, 3, 4, 5, 6, and there's 9 apples in each one. 1, 2, 9, 9, 9, 9, 9, 9. So this is making sense of the problem. How many apples are there in all? So I have 6 times 9. Now I can decompose this a couple different ways. There's a lot of different ways I can decompose this because I'm sitting here thinking about it. I could keep 9 the same, and guys, I'm going to stretch your brain just a little bit here. So I keep 9 the same, and why did I write 3? Because I'm going to have 3 factors instead of 2 factors. And then I'm going to decompose my 6 into 2's. And then I want to add all of them together. I didn't break any rules. I'm keeping 9 the same. This one's 18, this one's 18, this one's 18, and then I can add my 3 partial products together, 18, 18, and 18, to get to what my answer is. Now, could I did 5 and 1? Yes. It would have been easier. Yes. If I broke down my 6 to my 5 and my 1 and then multiplied 9, because I can count by 5s and then I know anything times 1 is itself. But I wanted to challenge myself a little bit more. So, we have 18, 18, and 18. That means I have 30 tens. And then I have 8, 8, and 8, which is 24 tens. So I would have 54. And guys, this is a 9 fact, so I should be able to add both digits and get to 9, and I did, so therefore, that's one of the ways that I can check. So, it would be, how many apples are there? 54 apples. Alright, and there's all my work and proof to go with it. They do not give us enough room in the book, so I can't work them out in the book, not with this little amount. Alright, so find the unknown. Oh, we gotta find what it is. 7 times blank equals 21. Well, I know it can't be 5 because it doesn't end in a 5 or a 0. Well, it can't be 5 because it would be 35, and if you went up one more multiplying, you're going to get higher, so it can't be that. So it's down to 3 and 4. This makes sense of the reasons. So if I have 2 7s, I have 14, and if I add one more 7, I'm going to get 1 and 2. That's not right. I'm adding. So it's 11 and then 2. That's 21. So 3 would be my answer. Flip that page over. And we have performance task. My sticky notes are under there. A performance task. This is seeing, these are connected more so to real world, like what you're going to encounter when you're out and about. The nurse needs to deliver medications to 7 patients, and it will take 8 minutes for each patient. How many minutes will it take to deliver all the medication? Ooh, represent 2 different ways to decompose to solve the problem. Alright, so the first thing we do is we always make sense of our problem. Now I know there's not a lot of room here, and if you've been using lined paper, you can work it out on that too. Just make sure to write down on your lined paper, part A. Alright, so the nurse delivers medications to 7 patients. So 1, 2, 3, 4, 5, 6, and I'm not drawing very big at all, 7 patients, and it takes 8 minutes. So I'm going to put an 8 below each one of these because it's going to take 8 minutes for each one of my people. how many minutes will it take to deliver all the medication? So I've got to solve it. So my equation is going to be 7 times 8. And it wants 2 different ways. Well, I can think of 2 different ways easily. How about you? Alright. So I can break my 7 down to 5 and 2. So it would be 5 times 8 plus 2 times 8. That's one way. Right? And then that would be 40. That would be 16. And 56 minutes would be my answer on this one. 56 minutes is how long it would take. Alright, 7 times 8 again. I can break my 8 down. I can break my 8 down and keep my 7 the same this time and have it broken down into 4s. And I know double 7 is 14, so if I double the 14, I get to 28. And when I add 28 and 28, I get to 56 minutes again. Represent 2 different ways to decompose. Did I represent 2 different ways? Yes, I did. And could I do more? Yeah, because I could even break down my 8 to 5 and 3 too. Also, sometimes using the word 2 in math that's not a number is confusing. But 2 also means the word also. The nurse provides medication to each of his 7 patients. Each patient receives 2 units of medication. They take the medication 2 times each day. How many units of medication does he need to provide medication? Goodness gracious, let's start that over. The nurse provides medication to each of his 7 patients. Each patient receives 2 units of medication. So if I have 7 people, 1, I'm going to draw a little bit bigger this time, 2, 3, 4, 5, 6, 7. Alright? So there's my 7 patients. Each patient receives 2 units of medicine. Okay, so a unit, we haven't got into measurement yet, can be cc's. But do you know how you have the little cups and there's different amounts on the side of that little cup? That 2 units could be 2 milliliters, 2 teaspoons. So 2 units is just like the 2 on the measuring cup. So I'm going to put 2, 2, 2, 2, 2, 2, 2. Alright, so each one of them gets 2. They take the medication 2 times daily. Uh-oh. So if they take it, let's read the next sentence though. How many units of medication does he need to provide to all of his patients in one day? Okay, so this is only once. So he has to do that twice daily. So each person is actually going to get 2. This is making sense of the equation. So each one of these people are going to get 2 times 2 units. So they're actually going to get 4 a day. They're just not at the same time. So how much medicine does he provide for all day? Show your work. So here's me making sense of it. So I would start out with 7, wouldn't I? And then I would multiply that times 2 because each one of them will get the first dose. And then I'd multiply it times 2 again because they get 2 of those doses. So I can do this and do my first one, which is 14, and then multiply 2 times 14 and get 28. Or I can do 7 times 4 and know that 7 times 4 is 28. But I need to put it in a sentence. Or how many units of medication does he need to provide in one day? So 28 units of medication for one day. Alright. Now, this would be a nurse that would be doing this, right? Because it says a nurse or a doctor or a nurse's aide. They might be even get the medicine ready. This is real life. This is what you're going to be faced with when you grow up. It takes the nurse 6 minutes to review and update the patient's chart. How long will it take him to review 2 patients' charts? Oh, look, and then it's 4 patients, then it's 8 patients, and explain. Ooh, I love these because I love doing charts. And we find the patterns, don't we? So it takes the nurse 6 minutes to review and update a patient's chart. So we need our 2 titles up here. So this is time, because we're dealing with minutes, isn't it? Time, not times, time. And this is number, this is the number sign, patients. Okay, so if you have 1 patient, you have 6 minutes. Well, if you have 2 patients, you're going to double that, aren't you? So it's going to be 12 minutes. If you have 4 patients, well, guess what? You're going to double it again. You're going to have 24 minutes. 8 patients, yep, you're right, you're going to double it again, which would be 48 minutes. Explain how you found your answer. Well, this is a lot of explaining right here. If somebody sees a chart, how you're making it, and I mean, if I wanted to go over here and put one more line in my chart and put equations, I could go, well, this would be 1 times 6, this would be 2 times 6, this would be 4 times 6, because each time it's 6 minutes, so we're going up by 6s, and this would be 8 times 6. And this is our explanation. I don't have to write any words. Alright, so now you're finished with that. You're going to, I'm going to have to take all these off, but you're going to tear out your pages. If you use the line sheet of paper, please, please, please staple it with it. I want to see all your work, because that lets me know that you're doing math and not magic. Sugary doodle, let go of it. So make sure to tear it out. If you want to just hang on to your papers to the Friday to be able to staple them, that's fine. But you will be stapling this to your work plan. So make sure you have it and staple. You don't have to staple it now, but you need to staple it at some point. And you're going to put your name on it and turn it in on Friday with your work plan.